Hey guys, in this video we'll explore the chain rule. Okay, so this is just one more rule to kind of add to the mix. We'll call it the chain rule, and I'll show you why in a second. But before we start, just to make sure you guys are actually doing what you're supposed to do, can you please look at me and blink twice? I'll be watching. Alright, so look at me, blink twice, let me know you're actually watching the video and not just like updating your Facebook page. Alright, good job. So the chain rule is for functions that look kind of like this. Suppose instead of like a product rule where you have like f of x times g of x, suppose you have f of g of x. Okay, and that's what we're going to deal with. So like, you know, if you had an example that looked like this, you know, 2x plus 1 squared, and based on what we know currently, you would probably have to split that up as 2x plus 1 times 2x plus 1 and either distribute and do some power rules or do a product rule. So let's actually do that just to kind of see. So if I do a product rule here, I'll do 2x plus 1 times 2 plus 2x plus 1 times 2. Okay? And if I simplify that, I get 4x plus 2 plus 4x plus 2, which of course is 8x plus 4. Great, no big deal. But what if that was to like the 10th power? We don't want to have to deal with that. So what we're going to do is we're going to do a chain rule. The chain rule simply says that when you go to take your derivative, you take the derivative of what's outside first, leave the inside part alone, and then you multiply by, and this is why they call it the chain rule, by the chain link that's kind of inside, right? You're going to basically make like a chain link, you know, I just want to keep saying chain. A link of chains, right? So you multiply by the derivative of what's inside. And if there were more functions hiding inside, you just keep going. Okay? So you do f prime of g of x, so you take the derivative of f, leave the inside part alone, then multiply by the derivative of whatever's inside. So you work from the outside in as far as derivatives go. So if I apply that idea here, f prime of x would be, okay, treat this as like a thing. It's just something. So it's something to the second power. So if I do my power rule on that, I'd have 2 times the thing, right? 2 times the thing to the first power times the derivative of the thing. Okay? So again, if this is just, think of this as like its own, you know, entity, like capital A. So I have capital A squared. So it'd be 2 capital A to the first times the derivative of whatever capital A was. Well, the derivative of what's inside is 2. Clean that up, 4x plus 2 times 2, which of course is 8x plus 4. Okay, much simpler. And again, it opens up the possibilities of things like this. What if this was 2x plus 1 to the 94th? Alright, I suppose you could expand that out and do a bunch of ridiculous product rules, or even distribute all that, but obviously we don't want to do that. So f prime of x would be 94 times the thing to the 93rd times the derivative of what's inside. Done. Yeah, I know, you can multiply the 2 times 94, but basically we're done. Okay, and that's the basic idea for the chain rule. So the derivative of what's outside, leave the inside alone, times the derivative of what's inside. Okay, let's try a couple. Suppose you have a function that looks like this. Square root x squared plus 1. And we need to find the derivative. Well, we've had a bunch of these square root type ones where you know to rewrite it first. Like that. And unfortunately, that's not something we can just like, you know, expand out. Okay? So what we would do is we'd use our chain rule. So I'd have 1/2 times the thing to the negative 1/2 times the derivative of what's inside, and you are done. Yes, again, I know we can simplify just a little bit. And if you're looking in, you know, if this is a book problem, negative 1/2. If this is a book problem, I'm sure they'll rewrite it like this. But as long as you realize that's all the same thing, you've basically done your chain rule as of this step. Okay? Obviously, as you're doing this, if you have any questions, just come up. I know some people might still be taking the quiz, but just let me know. Let's see, let's try another one here. How about a ridiculous one? How about something like this? Actually, let me get a new piece because I'm going to run out of room, I think. So suppose you have one that looks like this. Let's see, we got 2x plus 1 to the 5th times x cubed minus x plus 1 to the 4th. Alright, just pure ridiculousness, okay? Clearly you're not expanding that, so hopefully you realize that in here, you know, we essentially have a product rule, right? We have a function and a function. So we'll do our product rule as normal, but what you'll see happen is our chain rule is going to be kind of hiding inside. So let's leave this alone, 2x plus 1 to the 5th, times the derivative of this one. Now this one requires our chain rule. It's a power rule with a chain rule kicker, okay? So for the thing to the 3rd, right, power rule, chain rule kicker, 3x squared minus 1. That's the first half of the product rule. So I left the first part alone, that's here, times the derivative of the second part, which requires a power rule with a chain rule kicker. Okay, that's not a technical term, that's just what I call it. Alright, plus, that's only half the problem. We want the derivative of this one now. Leave this one alone. So the derivative of this one is going to be a power rule with a chain rule kicker. Okay, so 5 the thing to the 4th times the derivative of the thing. 5 the thing to the 4th times the derivative of the thing. And then the other one just comes along for the ride. X cubed minus x plus 1 to the 4th. Now, as far as I'm concerned, you just took the derivative, and that would be full credit. But as we know, some of these are multiple choice, and you want to check the back of the book, etc., etc. So we probably will have to simplify this a little bit. And by simplify, I don't mean expand. I mean recognize that you have 2x plus 1 terms in both parts. You have x cubed minus x plus 1 terms in both parts. So we're going to factor out whatever we can do, you know, whatever we can take out of both. So I got 5 of them here, I got 4 of them there, so I'm going to take out 4 of them. 2x plus 1 to the 4th. I've got 3 of these kind, and I've got 4 of those of these kind over here, so I'll take out 3 of them, because that's what's in common. And let's see what's left when the dust settles. We have a 2x plus 1 to the 1st. We have a 4. And we have, let's see, we took away all those, and then we have a 3x squared minus 1. Plus, on this side, we've got a 5 coming along for the ride. We took out all 4 of these, so those are gone. We do have a 2, and we have 1 left of these things. X cubed minus x plus 1. Plus 1. Okay, and then from there, yeah, I know it's not that pretty, but we actually should be able to simplify that, so just for the purposes of the video, I will. But again, this isn't calculus anymore, now we're just doing algebra. So let's see. If I do this, I get 6x cubed times 4, so 24x cubed. I've got 3x squared times 4, so 12x squared. I've got negative 2x times 4, so that's negative 8x. And I have negative 1 times 4 is minus 4. Plus 10x cubed minus 10x plus 10. I hope that's right. Alright, we'll see in a second. Let's clean that up one more step. X cubed minus x plus 1. Alright, let's see, what do we got left inside? 24x cubed plus 10x cubed is 34x cubed. That takes care of those. 12x squared, I don't see any others. That's 12x squared. And negative 8x minus 10x is negative 18x. And negative 4 plus 10 is 6. And could I take out something else? Oh, geez. What can I do? Take out a 2, I guess? So 2x plus 1 to the 4th, x cubed minus x plus 1 to the 3rd, 17x cubed plus 6x squared minus 9x plus 3. I don't think I can do anything else. Let me just double check it. And I think we're good. Okay, so technically this would be your final answer, but again, if you could get to this step, where is it? If you can get to, nope, this step, sorry. If you can get to this step, then you know the chain rule. And by knowing the chain rule, what I mean is you know all the other rules too. I mean, we had a product rule in here, we had power rules in here, and then the rest is just literally algebra 2. Alright, I think that's enough to probably get you started. Why don't you try the book problems first? They're up on the board. I can't see them from where I'm sitting, but they're up on the board. Go ahead and give those a shot. Check your odds, obviously in the back of the book. The evens are already up on Edmodo, so feel free to use your phones to access Edmodo and check the answer key. And let me know if you have any questions. Okay? All right.